like 10,000, it could be millions or tens of millions. So that's the other way we try to solve this problem.
Can I ask two questions quick?
Sure, yeah.
So one question is, each microchain, do they have their own tokens or they all use the same tokens?
Well, they could have tokens. They could not have
What
no
are they paying
tokens.
validators?
Well, they have like 100 miners inside that microchain.
Right, but are miners paid in the token specific to the chain, or they paid in the token?
That's a
which
very
is
good question. So that's a very good question. That's another problem we try to solve. So when we look at the Ethereum smart contract, who's paying the fee? It's user, right? User call the smart contract functions and they pay that, which is actually is a pretty limitation to the Ethereum, because every user want to use the application, they need to get some Ether first, and then they then can start use your smart contract-based application. We think that's a major drawback of the blockchain, public chain. So what we do is, let's look at that. So someone has to pay the system, right? If it's not user, who's going to pay the system? And we think, hey, it should be the app developer or the app owner paying the fee. So if I develop an application and I select 100 nodes or 200 nodes from the pool to support my microchain, it should be the app developer paying those 100 nodes. And they're paying in form of the bottom layer token.
But then how to prevent loss? The user does not pay. Because of cost.
That's another good question, and we're trying to solve also.
Or we'll repeat the, we can
Oh, okay.
we can repeat the question, we just couldn't hear it.
Yeah, so she asked, like, if there's no token, how to provide a DDoS attack?
If user doesn't pay.
Right. So that's a very good question. So the way we solve this is because the very unique features of our system. So we have microchain on top of it, and we have motherchain on the bottom. So the nodes inside the microchain, they don't talk to each other directly. They actually route through the bottom layer and reach the other nodes in the same microchain.
So I think the question is not how to prevent DDoS in terms of network DDoS. The question is how to prevent a malicious user from depleting
Yes.
Yeah, so that's basically in the bottom layer, we implement a access control and resource control. So because no, this is not permission based. It's access control and resource control on the bottom layer. So you don't control it on the top layer, but on the bottom layer. And now you can get rid of the token on the top layer, but you still have tokens on the bottom.
So how do you scale if you have to, if your top layer is a scalable one, but you have to route your service path touches the bottom layer, so you have a dependency in terms of scalability.
Well, that's a very good question. That's a very good question. So basically,
Repeat the question.
I'm sorry?
We repeat the question.
Yeah, the question is, because every communication needs to route from top to the bottom, and the bandwidth is limited, right? That's a very good question. So there are two ways to answer this. So first, the bandwidth in the bottom layer will define the maximum TPS the system would have, right? Given the bytes per packet, and given the bandwidth of the lower layer, you can calculate the maximum TPS you can have. It's the number within, it's about like 1,000 to 10,000 or 20,000. That's the limit. But that's based on assumption, meaning the transaction in a broadcast way. If we could construct a security channel on the bottom layer so that will route the nodes inside one microchip to another node in the microchip through the security channel, you are no longer limited by the bandwidth. Remember, right? Think about it. So in that way, the whole system TPS will not be limited by the, like 10,000. Yeah.
Thanks for, or we'll hold the other questions for later. We'll have time very soon. I want to ask the audience something. So how many of you guys have worked and tried to create a DApp? Just raise your hand if you've created a DApp or tried to create a DApp.
Is ICO considered?
Let's, I mean, sure, let's say it is. Alright, awesome. Now, keep raising your hand if you've tried to create a DApp on top of a Sharding network. Alright, so quite a few less. So maybe we could just talk about use from a DF, creating a DF perspective to work on top of a sharded network. Romjan, do you want to try to take it first?
Yeah. So I think in the sharding space, DF should be, like for the developer, it should be a kind of agnostic to the developer, because we don't want to expose all this sharding complexity of cross shards feature to the developer. It will make the work even harder, because right now it's already very complex, complicated. So, but right now, one of the key questions in sharding is how to do cross-shard smart contract. And now a lot of projects can support cross-shard transfer, because it's kind of simpler. You just need to, something similar to atomic swap in the Quarkchain. You just need to lock some of the token and then create a new token in the other shard, so you can transfer the token. But for cross-shard smart contract, there will be a lot of complicated logic. If your smart contract touches multiple shards, the data in multiple shards, how do you make all of this execution consistent and all the data or state consistent? So this comes to like a kind of famous question of the hotel and train problem. It's like for your application, you want to like execute two things in an atomic way. You don't want it in a state of half done and half not done. So if you have an application that's calling a smart contract in one shard that's booking your train ticket, and in another shard that's trying to book your hotel, you want this atomic operation. So this is one of the major questions that all this sharding-based blockchain should answer. So some of the compromise we can make is we can limit or force all the smart contract to live in a single shard. But this has a problem of the limitation of one shard performance, right? One shard performance probably can scale about 1,000 or a couple thousand, but it's not taking advantage of the whole sharded blockchain. So in this kind of cross-shard smart contract space, there are a lot of really new research. One of them is called chain space, which really like define this data model. It's more like a UTXO-based data model, where every object or state is an object, and the transaction executing on the object will first consume it, like delete the object, and then after all the processing and all the coordination between different shards, all those like consumed object will be deleted, and new state will be created as a new object. So in this way, you can sort of achieve this atomicity operation across shard. But the problem with this, you need a lot of coordination between shards, and that's very costly. So all this cross-shard smart contract, after you implement it, the throughput will probably even lower than the non-sharded network in the current state. So that's not only latency, also the throughput. So that's kind of a major question, like for all the sharding-based blockchain.
Yeah, thanks for the answer. Oh, sure.
I have some also a few basically thoughts regarding this. So I think with this underlying sharding infrastructure, imagine like some also like some Facebook, Google, they also provide a bunch of the sharded infrastructure, but also you'll be some applications responsibility to be aware of that and to be able to actually handle that. So that, for example, key technology behind sharding is basically state partition and process parallel. And some of the application itself, when designed for something that should also design for that. But some applications, it has to rely on some global state. Like for example, if we want to have some integer operations to perform atomically, then no sharding solution can address it, because like we are not able to basically need some kind of global locking and do some operation and unlocking. And even sharding or multi-threading doesn't help. So it must highly depend on some specific applications able to adjust that. So for example, for like maybe ICO, which has a global state that, like for example, the cap of the ICO that want to raise. And if we want to build a sharding smart contract to be able to, for example, determine that everybody is exactly reaching within the cap,
then no sharding solution can do it because the total amount of money raised in different shard must be an atomic integer, and it's impossible to do sharding. We must acquire some log to make sure that it is being synchronously updated atomically and consistently. And one way to compromise this, basically, we can split this cap to half, so that we can have two shards basically process half of these ICOs, and so that they can run in parallel. And this is one way that, from an application perspective, they have to design in order to increase the capacity if we really want to adjust this problem. Another problem, for example, voting problem or this problem, as long as it's an overall state, we need to synchronize them. We have to think of what way to compromise it and make it find a trade-off solutions. And this is, I think, some applications has to really do it. And for example, hotel and train problem, and I think this is also some kind that, because there's global state that needs to achieve, then it has some applications may be able, for example, attempt to lock a hotel and try to acquire the whole the chain and then finalize the transaction using multi-state phase transaction to achieve that, right? But I think still, like, we still have some sacrifice. For example, if we can put in the single shard, then I can just get in one transaction without doing multiple stage transactions, which in some sense, it may be worth the performance. So I think this is highly application specific. I won't say any applications is able to be speed up by sharding, but since we can always put all the states in one shard for some smart contracts, so definitely it can still benefit from it because the network will be less congested.
So I'd let you go. We're getting close on time. I want to turn it over to Q&A. Is that going to hurt you too much, or you really want to say it?
It's pretty quick. So the quick thing I wanted to say is that we're probably not going to need smart contract sharding anytime soon. The most popular contracts today, IDEX or CryptoKitties, they have between 500 and 1,000 active users per day. It's pathetically small. If you think CryptoKitties are wildly popular, it is not the case. They're just wildly expensive. And the second point I want to say is that if you guys want to look to read more about interesting solutions to train and hotel problem, one interesting solution is called yanking. So it's something you can Google. It's Vitalik's proposal. It's somewhat interesting. It still logs the hotel, but it's simplifying significantly the continuation of the process.
All right, thanks. Yeah, we can take a few questions live from the audience. Also pull up Slido, but we can take the first hand there. And if you want, you can either, it's okay if the speakers just repeat the question.
Okay. So one thing, I guess, I don't know if all your designs have this property, but Alex, you mentioned that one of the tunable parameters is how often you reshuffle the shards, so how often one set of nodes switches what they're responsible for. And that a bottleneck there is that every time you reshuffle for the next round, you have to send all that data over the network to the new nodes that need to be responsible for that shard. So there's the bandwidth bottleneck, but then also there's like an incentive question, which is like if I'm a validator in one set of shard, or one shard, next round I know I'm going to be in another shard, my incentive is to get the data for that new shard so that I can start earning rewards in the new shard. But what's my incentive to spend bandwidth serving data to the new nodes that are taking over my shard? And how do you guarantee that that data is available to the next set of nodes after a reshuffle?
So the question is, if we have validators which are being reshuffled, what's the so clearly they have an incentive to download data for the next shard. What is the incentive to give data?
Yes.
And so we personally spend zero effort researching it. If you think about this problem is not specific to sharding, it's exactly the problem in blockchain. What is the motivation to reroute transactions? Why not just hold to them? More importantly, in blockchain, you actually are incentivized to hold onto transactions because they have fees. So if you find a block, you have those tasted transactions that you can include, and if you route them to someone else and they find the block, you're losing that fee, right? And yet in practice, in Bitcoin, people are routing transactions. So the idea here is that in practice, most likely, if in your binary, in the vanilla binary people can download, data is being served. It is unlikely that many people will try to tamper with the binary to reduce the bandwidth. So at least with NEAR, when we launch, there's going to be no incentives to give data away. Once that becomes a problem.
Ethereum already is having problems with like peering data and finding like good peers to sort blocks.
Then we'll have to figure it out before we launch.
Great.
Yeah, actually, yeah, we have a solution for his question. So basically, how you can create a shard you want to have a different shard, how to migrate data from one shard to the other, another shard, that's typically a data-intensive operation. And the solution is, we just don't do the resharding. So basically, in our scenario, we create a microchain, which random is selected, which the security be pretty much like statistically guaranteed initially, but over time, those nodes could rule and could be bribed, right? So our way to solve this problem is we have a retirement mechanism. So basically, for us, we have a periodic process which will flush the microchain state onto the bottom layer as a finality check. So at each flush state, we could retell certain percent of the nodes randomly. So that will solve another problem you have, like how if I close to the end of the shard, I'm not willing to give data to the other person, right? By that way, random nodes will be selected to retell, so you don't know beforehand, so you don't have this problem. So we have a periodic flushing mechanism, flush the state to the bottom layer, and also introduce retirement scheme to prevent the included nodes and also prevent combination.
You also do compactions after?
I'm sorry?
You also do compactions after you flush?
What you say?
So the question is, do you also do compactions after you flush?
Oh, the flush is we only flush the hash. We don't need to flush everything. And actually, it's not possible to flush everything.
Well, the question was, for any node, what is the motivation to serve any data to anyone else?
Because you are in our microchain, you are proposing blocks, and you got rewarded by each block.
So you propose block at timestamp 5.
Yeah.
1 year from now, what is the motivation for any node to give away the data when it is requested?
Because if he's not getting data, he's not able to continue proposing blocks.
Okay. I'll do one from Slido first, and then we can come to you. So the one from Slido here is, how often do you think it's necessary to reshard these nodes, or you don't reshard at all?
Yeah, so the reason why I reshard is because we're trying to prevent the adaptive adversary attack, right? Because after even your sharding is secure, like using this unpredictable randomness to shard, and the structure is secure, but over time, one of the shard may be attacked or overtaken by some malicious party by even bribery or any collusion. So we need to kind of reshuffle all the shard and nodes to make sure none of the shard is corrupted or is compromised. The time or the frequency really depends on how you think or how you assume the attacker can corrupt a single shard for it to reach the security threshold. And I think for the like a reshuffle question, I think answering to your previous question about how to like quickly sync up to the new shard with all the state data, right? So one of the solutions is we can use this like blockchain pruning, kind of package all the states into a single state block, and then make it a genesis block, and then everybody, all the new nodes in that new shard can just download the state block, which is very small compared to the whole history, and start kind of verifying the transaction very quickly. So this is one of the solutions. I think another solution is you try to separate the role of all those validators. Some of the validator only like execute or add the transaction into the blockchain. Some other validator is called a proposer. What they did is just run consensus on what kind of transaction they're going to propose, but they don't check the state. So for those proposer nodes, they don't even need to download the state when they switch shard.
What's your answer? Sure. From the audience.
So, can I answer the question from the...
Oh, from the
Because
slide.
that was the answer to the previous question.
Sure. You can do this first.
So I will answer from perspective of Ethereum because there's nobody from Ethereum here, and they actually have a decent solution.
Sure.
And their decent solution effectively says that. So first of all, when you think of security guarantees, it is important to observe that even if there is one honest validator in a shard, it is very hard to compromise the shard, because once they send the state to the anywhere, so it doesn't matter exactly how it works. They either send it to the bottom chain, beacon chain, or they just publish it. If there's at least one honest validator, there are going to be 2 states published. And when there are 2 states published and both of them have some stake behind them, that is a motivation for the entire network to go and check what is happening, because someone is going to get slashed, and whomever slashes them will get money. Right? And so you will see everybody on the network go there and figure out who is wrong. Even if the malicious actors have 99 validators and there's one honest, the entire network will ultimately validate it.
But if the benefit is greater than slash penalties, what happens?
Benefit for whom, right? When everybody comes there, for them the only motivation is slashing, because
So the question, or what you're saying, if the benefit is greater than what you get from slashing.
but for people who are not validators, the only benefit is slashing. They're not getting any reward except the slashing reward. But then the Ethereum's proposal is effectively, it says that validators are working for a somewhat long period of time, longer than it would take for the adaptive adversary who's super good to corrupt them. But on every single block, there is another role of notary, and notaries are rotated super frequently. And the notaries are just running some sanity checks. And the idea is that because notaries are rotated super frequently, there's not going to be too many adversaries. Adaptive adversary has no chance of corrupting them. And so notaries would, at the very least, verify that the data can be downloaded, so the data is being served. And then they might or might not also validate some transactions, which do not require, like in this case, they don't have to download the entire state, they can download the parts of the Merkle tree that are affected.
Gotcha. All right. Well, we only have time for just one last question. I know that in the green you had one. I know in the white as well, but I'm pretty sure you can catch these guys afterwards as well. So don't have your hearts broken.
The question was about storage pruning. You keep after a few epoch, you will lose the state. You don't keep the entire application state of the blockchain. So you just keep the last hash after archiving the blockchain.
So basically, we're talking about like the flush step. So basically, all the state was stored in the microchain untouched. So, but we still want some kind of penalty. So what we do is periodically we flush the transaction hash from the last checkpoint up to now, and then flush the hash into the mother chain. So in that way, we get a checkpoint of that microchain. And so that created a useful features for other applications.
The question was about harmonious pruning, right?
Yes. Oh, exactly. So that in storage pruning, after a few epoch, you will eventually lose the history of the entire state.
Yeah, so our designs do refining, but the point is there shouldn't be everybody like losing all the history, right? There still be some nodes keeping the full history.
Which node?
Yeah, for the node who have bigger storage, they can like volunteer to store the whole history. But for some of the nodes that need to reshuffle, those nodes don't need to store.
No smart contracts then, because you cannot keep state between the smart contracts.
Well, it's only the history that is pruned. The state is obviously kept.
Exactly. But then still you need a history of the chain for
So to answer that question, one interesting thing you can Google is called Coda. Coda is compressing the entire history, but keep a proof that history is legit.
Of course, but since the validator node is being reshuffled, how do you still keep the data or the inside the validator's consensus?
We can repeat the question too.
So the question is, if the validators are shuffled, how do they keep data? So the idea is that so state is never pruned. The latest state is always available, and so the validators.
Of course.
Right. So when the validators knows which shard they are being rerouted to, they need to know it in advance. Obviously, they just download the state from whomever has that state at that point. And that was exactly the question before. How do we encourage people to serve the state? And the answer is
With pruning or without pruning?
Hmm?
Are we talking about with pruning still true?
Well, we're not pruning the state, we're pruning the history. History is not needed to continue operating the network. So there's a blockchain history which has all the data. 2 terabytes of data in Ethereum is history. 100 gigabytes is the present state. Present state is never pruned. The history is pruned. Either with a proof, that would be code approach, or without a proof, we're just hoping that socially people will agree on the new Genesis block.
Yes.
Yeah. But the idea is that the state is never pruned. State is always fully available. And so when validators move to a different shard, they download the entire state.
I was talking about the history. Sorry, not about the state.
Well, validators don't need the history. If they either believe the new Genesis block, that would be some sort of proof of social, proof of Vitalik, or proof of.
And obviously it has the state of the last finality block steps.
Well, then you have all the long range attacks and things. Well,
Yeah, so that's a benefit if you do not do reshuffling.
Nice end to it. So yeah, I want to let everyone thank the panelists here today.